Invisibility is one of the most tantalizing powers in fiction, spanning all kinds of stories. But could this fantasy ever become a reality? Well, invisibility is a relative term. Researchers and engineers working in stealth technology have developed planes nearly undetectable to radar and cloaks that conceal tanks from thermal cameras. But these innovations don't make things invisible to the human eye. Our eyes see by taking in the visible light waves that reflect off objects. So to make an object invisible without turning off the lights, our eyes would need to see the light from behind that object rather than the light bouncing off the object itself. And to do that, we need to be able to control these visible light waves. One way to do this is through reflection. This method is predictable, but it requires maintaining angles too precise for most moving targets. Researchers can also absorb light with ultra-black surfaces covered in light-capturing nanotubes, but painting something black doesn't exactly make it invisible. So instead, many researchers are trying to reroute wavelengths around an object using refraction. Refraction describes how light changes direction when it passes between materials of differing density. When light passes from a less dense medium into a denser one, its path gets slightly bent. Consider how someone's legs look when you sit at the edge of a pool. Since water is denser than air, the light waves reflecting from the water to your eyes speed up and bend. In nature, this effect has limits, even when passing through natural materials with the highest refractive indexes. Light can only bend so far. But in the lab, we can shatter those limits. In the 1990s, theoretical physicist John Pendry was working with a defense lab to create a way to absorb radar signals. The result was a mesh of carbon fibers, so thin and densely woven that they interacted with light in an entirely different way from regular carbon. This inspired Pendry to try similar tricks with other materials. By altering them at the microscopic level, Pendry could add tiny microstructures capable of capturing and bending light in ways previously thought impossible. He called this technology metamaterials and developed his most famous example, a split-ring resonator, a metamaterial structure which allowed him to bend light past the theorized limit. The discovery of negative refraction kicked off the modern wave of invisibility research. To date, labs have designed metamaterials that can completely steer away microwaves. But a true invisibility cloak would need to bend all wavelengths of visible light simultaneously and without distortion, and refraction doesn't treat all wavelengths equally. Consider how refractive materials produce rainbows with varying colors. Despite leading the field, metamaterials aren't the only route toward invisibility. One lab was able to create a controlled desert mirage using hot air just above the ground to refract light from the cooler air around it to create distortions and illusions. Unfortunately, this model only operates at thousands of degrees. Another lab created a unique configuration of glass lenses, which can bend the light around an object within a ring-shaped area in the lens. This lens could be made large enough to obscure an entire person, but its effect only works when both the observer and the obscured stand in the exact right positions. And attempts using cameras to record environments and project them over a cloak have been hindered by lag and color distortion. These efforts and many more still have a ways to go towards bringing this magical technology to life. But if one thing is true about science, it's that the limitations we see today could simply disappear